All right, hi everyone, thank you for coming. So this is our talk, Kubeflow at Spotify, building and managing a centralized platform. It's not going to be as technical of a talk, it's a little bit more of a case study of how we deploy Kubeflow at our company and the sort of trials and tribulations and things we had to consider along the way. I hope that you can take away something, if you're not using Kubeflow yet yourself, that you can maybe take something away about how you might use it in your own organization. So as mentioned before, my name is Ryan Clough, and this is my colleague Keshi Dai. And we're going to start by talking a little bit about Spotify, and we're going to cover a bit about our organizational structure, because this is going to inform the decisions that we made around centralizing Kubeflow as a platform. And then I'll talk a little bit about how we can optimize the development experience using this centralized resource. And then Keshi will take over and talk about how we built the platform, how we manage it, and some of the lessons learned that we had along the way. So we're Spotify. If you haven't heard of us before, we are a music streaming service. We also have podcasts, and we launched in 2008. We have 248 million active users, 50 million tracks on our platform, and we're launched in 79 countries. We use machine learning all over our products, most notably in our recommendations products such as Discover Weekly, which is a weekly personalized playlist that we provide for our users. But it's also in many other places such as our search functionality, our homepage, and much more. I'm making the assumption that a lot of you know what Kubeflow is, but in case you don't, the brief elevator pitch is that Kubeflow is an open source framework for running machine learning pipelines on Kubernetes. It transforms individual components of the ML workflow, such as training, transformation, model evaluation, etc., into individual Docker containers that can be chained together. So let's talk a little bit about the organizational structure at Spotify. I know this is a Kubernetes conference, so why talk about this? If you're familiar with Conway's law, it's that software systems tend to reflect the structure of the organization in which they're built. And so I don't want you to go back to your office on Monday and say, let's adopt Kubeflow and let's deploy it this way because this is the way that Spotify did it and it works for them. I want you to see the trade-offs that we made and how they relate to our organizational structure and use that to inform your own decision-making process as to whether this would be right for you and what kind of trade-offs that you need to make. So we're going to start the story with you. I'm going to put you in our shoes. You're now an engineer at Spotify. Congratulations on your new job. You're on a team, and teams at Spotify we call squads, and your squad is machine learning infrastructure, the team that Keshi and I work on. You are one squad of 280 squads all across the globe. We have offices in Stockholm, New York City, which is where Keshi and I are, London, Boston, and more. And these squads sort of bubble up in a short hierarchy into business units. For example, our free product, our premium product, and other business units. Some smaller percentage of these squads use machine learning, and they're now your customers as a machine learning infrastructure engineer. So what does a typical customer team look like? Squads at Spotify are small, cross-functional, and what we call responsibly autonomous. So a given team may be constructed of any number of backend engineers, front-end, data scientists, data engineers, ML engineers, etc., based on the particular product or feature that they're working on. This is opposed to organizational structure that you might call vertical or centralized, where there's a single machine learning team. At Spotify, individual machine learning practitioners are embedded on cross-functional teams for specific features or products. This autonomy and decentralization is a trade-off for speed versus coordination. We trust teams to make the decisions that make the most sense for them and in order to execute as fast as possible. And this means that teams are not blocked on needing some resource from another team. They should be staffed in accordance to what they need to deliver their feature. The cons of this is that there's a lack of standardization. If you work in the ML space, you would know that there's a lot of different tools that you can use in ML, and new ones are coming out all the time. And autonomous teams means that all the different machine learning teams historically will be using a different tool set. And this leads to a sort of information or experience siloing. So there are maybe teams that have been around a while and built infrastructure around the tools that they use, and younger teams that are just starting to use machine learning may choose to use different tools that are technologically incompatible with the infrastructure that they built for themselves. And then there's also the problem of, we have teams in different time zones, in different countries, and different business verticals that may not have exposure to what other teams are doing. So given this organizational structure, you're posed with a question. For you as a machine learning infrastructure team, is it better for you to create a centralized resource for your customers to use and take on that operational responsibility? Or is it better for you to make the self-deployment use case as easy as possible for your customer teams? We're going to start by considering the self-deployment scenario, because for an autonomous team, this seems like the natural choice. It's very common at Spotify for teams to own and operate their own resources. As I mentioned before, we trust teams to know what's best for them, so they know what sort of scale and cost that they need to have. And they don't have to worry about fighting over resources within the cluster or worrying if some other team is going to do an upgrade that will break their production pipelines. So what does your job look like in this kind of a scenario? Well, first and foremost, you're going to want to deploy Kubeflow yourself and figure out what kind of customizations are needed to fit within your infrastructure or networking system, et cetera. And then use what you've learned to provide a tool or a script to make deployment easy. Then you want to build on top of Kubeflow and provide common components for ML tasks that your teams are going to want to use, or components that will integrate with maybe internal infrastructure that you already have that maybe isn't publicly available. This is particularly attractive because it's the least amount of work for you. And as we know, good engineers do just as much work as they need to. In this case, you don't have operational responsibility. You're not on call at 2 a.m. when someone's pipeline breaks. There's no long-term resource planning around, how do I make sure that my cluster is going to scale to the future of machine learning at Spotify, et cetera. But as you begin to work on deploying Kubeflow, you're going to notice some drawbacks to this situation. And the first is that the amount of Kubernetes expertise you need to deploy and then long-term manage the cluster is actually a lot. And while you can minimize that by providing, say, a deployment tool, and the fact that Kubeflow abstracts away a lot of the Kubernetes details, there's still going to be the case where all of these individual teams have production pipelines running, and something at some point is going to go wrong on their clusters, and they're going to need to debug it. And if you made things too easy for them, they're not going to know enough about Kubernetes to debug it. They might be calling you anyways for help. The next situation is you need to consider how this scenario is going to work out long term. So we already have this information siloing problem where individual teams build up expertise and infrastructure. And if they have their own Kubeflow clusters, you're still going to be hiding the work of teams that may not have a natural level of exposure to other teams. We have some inspiration within Spotify already for this sort of problem. We have a centralized developer platform that you can log on to and see information about all sorts of pipelines and backend services at Spotify. You can see their status, you can see what team owns it, you can see where the code is for that service or pipeline, et cetera. I think you would be really lucky as an infrastructure engineer to expose the same kind of information about machine learning within your organization. So for example, a team that's working on a new model can look at the work of other teams. They can look at what data sets people are using, how people are transforming the features from that data set, et cetera. And that's going to be really hard to do if every team has their own cluster with their own metadata store, and you have to figure out how to coalesce all of that information and get the permission from everybody else's resources. Excuse me. The next situation is the upgrade scenario. So Kubeflow is a relatively young project, and they have quarterly releases that come out with all sorts of new and amazing features. But the situation here is that you'll often have breaking changes. And in an autonomous team scenario, you can't force a team to upgrade. And so if your team is trying to build on top of Kubeflow and make assumptions about what kind of features are there, what version people are running, you need to worry about whether or not you can get teams to upgrade to use your new features. And Yeah, basically, if there's going to be breaking changes, you also need to get the team to take the time away from the work that they're trying to do and deal with this breaking change, migrating their stuff that they may not have scoped for their work in that sprint or quarter, et cetera. Lastly, there's a bit of a technical detail within Spotify that was really important to us. I don't want to go into too much detail about it, but it was sort of the nail in the coffin for why we decided to centralize. And that's our usage of what's called a shared VPC. The story goes like this. At Spotify, we're entirely on GCP, but this concept exists in many other cloud providers. Because we're autonomous, every team has their own individual GCP project. And as you might imagine, it's common that services that one team builds is going to want to communicate to services, other internal services at the company. The problem is that by default, because each of the products have their own networking isolation, you can't do this. So to solve this problem, we use what's called a shared VPC, or virtual private cloud. It's a shared networking layer that individual services can connect to communicate with each other. So you might be thinking, okay, you've solved this problem, you have the shared VPC, just have the teams add their Kubernetes clusters to it, and that's the end of the day. The issue is that this is actually a pretty high friction process. So every individual team now, in the future, and if we have restructuring, is going to have to talk to security because you're attaching to a networking layer that exposes internal services. You have to talk with the networking team that owns the shared VPC, and they have other responsibilities. And if you have all of these teams bottlenecking on a single team to deploy like subnet allocations and stuff, that's a lot of work. And then you have to consider the fact that everyone's going to ask for more resources than they need. And there's a limited number of subnets, for example, in a shared VPC. And then lastly, there's a lot of special configuration for GKE and Kubeflow. And this is not really a common case for a lot of people. And we had to figure out a lot for ourselves. And it's fairly difficult to do. So to ask every individual team to do this themselves is really high friction. And if you're an infrastructure team and teams don't have to use the tools that you make, this is a huge blocker for teams that might just want to keep using what they already have. You want to try and optimize a bit for adoption of your tools. So given that, let's look at the pros and the cons of the centralization use case. Number one, our shared VPC problem is solved once. People don't have to worry about it. Number two, all of the Kubernetes expertise is now centralized on our team. That means that teams no longer have to worry as much about the infrastructure underlying Kubeflow. And that's the whole point of Kubeflow. Teams can focus on machine learning and not the infrastructure. Lastly, that means you get easier adaptation from the teams. All they have to do is use the Kubeflow DSL and submit it to the cluster and not have to worry about anything else. And lastly, for the future, you can utilize that centralized metadata and expose it in your already existing centralized platform. I'd be remiss not to mention the downsides of this situation, which is number one, we're a pretty small team and now we have this big operational responsibility. We have to go on call for it, we have to make SLOs, but this con may not be so much of a con when you consider the fact that it's either us taking the burden of this responsibility or every single individual team. Which in that case, you might not consider it a con. Someone has to take that burden. And as an infrastructure team, I would argue that perhaps infrastructure should be taking that burden, not the feature teams. Second is that it's a much larger risk surface. So you have many tenants and you have to worry about how they're going to be sharing the resources, if one team is going to accidentally hog up the resources from another team. And then the upgrade scenario, if you upgrade Kubernetes or you upgrade Kubeflow, if you break people's pipelines, you're breaking all of machine learning at Spotify, not just one team. And then lastly, Kubeflow is not yet fully multi-tenant, but that's coming soon and we really look forward to that, hopefully early next year. So given some centralized resources, so as I mentioned before, we have decided to centralize given these pros and cons. So given that, how can we optimize the developer experience? Number one, as I alluded to before, we provide a number of common components. We standardize on TFX, or TensorFlow Extended. It's a framework that's opinionated and provides a number of pre-made components and runs on Kubeflow. We have our own internal fork that utilizes all of the stuff that they've written for common tasks, so we don't have to write that. And then we can focus on tasks that are specific to Spotify or that don't exist in TFX. And tasks, for example, like accessing our data infrastructure. That it's not a public system, so we want to bake that into the components so that our users can use it. And then we want to build on top of Kubeflow. So we provide our users with a template repo that they can clone, and we'll fill in a lot of the pre-existing information about the centralized cluster. And this reduces a lot of boilerplate, helping adoption. And then we also provide a thin CLI tool that utilizes, once again, a lot of the assumptions around the centralized resources. So we know how authentication should work. We know what clusters things should be submit to. We can also enrich the metadata that's being sent when they submit a Kubeflow pipeline to our infrastructure. And then lastly, as an added benefit, we can build other tooling into this, such as scaffold. Our users don't have to write or compile or build Docker containers themselves. They merely interface with the Python DSL, and Scaffold will build the Docker containers for them as part of pipeline compilation. And lastly, this thin layer also helps us with the upgrade scenario where, for example, if there's some breaking change, we can sort of migrate users for them using this thin layer. And with that, I'm going to hand over the reins to Keshi, who's going to give a little bit more detail around how we deployed our centralized resources, how we manage them, and some of the lessons we learned with that.
Thank you, Ryan. Let's first talk about how we build our cluster. Before I dive into details, I want to remind everyone again that everything we do is on GCP. This significantly simplifies a lot of our work with the help of numerous Google Cloud offerings. Our story of building a centralized Kubeflow platform started May this year, and it has gone through several iterations. In the very beginning, we started with out-of-box default deployment tool. Later, we switched to Terraform to create and manage GCP resources, and use KSonnet to deploy Kubeflow apps. Eventually, with Kubeflow 0.6, we replaced KSonnet with Customize. Next, I will show some happy experience as well as some pain points in this journey. When we started experimenting with Kubeflow, we used the default deployment tool. It relies on Google Deployment Manager to create GCP resources and use KSonnet to deploy Kubeflow apps. The default deployment tool comes with a nice web UI with a few parameters. It builds a Kubeflow cluster with a public URL through Google Cloud endpoints, so people can access it immediately after it's created. Meanwhile, the access is protected by IAP, Google Identity Aware Proxy Service, so it will be as secure as other Google services. So this tool is really, really simple. It seems perfect for us since we run everything on GCP. However, it might be too good to be true. First, the whole process is a black box. We didn't really know what's going on behind the scene, so it was impossible for us to do any customization. All we could do was waiting for the cluster to magically show up. And second, it has no support for shared VPC. As Ryan mentioned earlier, shared VPC enabling is a requirement for Spotify's centralized platform, so teams can run jobs to access services in other projects. Lastly, there was no option to upgrade. In our case, we would like to retain certain resources, so upgrading cluster would not lose our users' data. To address those problems, we started using deployment command line tool, KF control, to build our Kubeflow cluster. It first generates all config files required by the deployment. Then it creates a cluster and installs Kubeflow apps in order. Because this separation between GCP resource creation and Kubeflow installation, we were able to modify the config file and add our own customization, such as shared VPC subnets, Cal SQL instance, and persistent disks. However, it still has a lot of problems. First, the customization was hacky. We didn't know much about KSonnet at the time. We ended up with manually editing many settings, as well as creating our own KSonnet lib file. Those manual steps are not ideal and cause upgrading and creating replica extremely hard. Moreover, KF control doesn't support context, so it was very error prone and a simple human mistake could destroy the cluster. It happened before. Once I forgot to change the context when I upgrade the cluster, and I accidentally deleted the entire namespace on different cluster. So tip of the day, added context and namespace to your shell command prompt. It helps a lot, at least for me. On the other hand, Spotify backend platform team is using Terraform to manage their GKE clusters. Those clusters are also configured to use shared VPC. So why don't we consult the Kubernetes experts in our backend platform team and also use Terraform to manage our GCP resources? We started to investigate this option in June. So what is Terraform? Terraform is a tool for building, changing, and versioning infrastructure safely and efficiently. With Terraform, KF Control is no longer in charge of creating and managing GCP resources. Our entire infrastructure stack is defined in a Terraform module, which includes a GKE cluster, Cloud SQL instance for metadata, persistent disks, service accounts, and a lot more stuff. Terraform also configures shared VPC network settings, syncs Kubernetes secrets with GCP service accounts, and manages database users, as well as cluster RBAC roles. By using Terraform module, we can easily replicate our cluster for different environments by providing a different set of parameters. So far, we have seen a lot of benefits of using Terraform. First, there are many existing examples we could learn from backend platform team, which dramatically lower the barrier of managing our platform. Second, it's really easy to rebuild, modify, track changes to our infrastructure. It becomes less intimidating now. Third, creating a replica is easy with Terraform module. We use it to build 3 clusters for our platform, one for experiment, one for dev, and one for production. Finally, we are also able to use existing internal tools that have been built for Terraform. For example, our Terraform config deployment has been integrated with Git workflow. So when we make changes to our infrastructure, we open a PR, and our build system can plan the changes ahead so they can be reviewed by peers before being applied. If the build system detects some resource is going to be deleted, the PR will be automatically blocked, and it needs administrative privilege to merge it. Because we believe resource deletion needs extra attention to avoid any mistakes. At this point, we were pretty comfortable of using KSonnet. After KF Control generated all the Kubernetes resource, we use KSonnet to set parameters for different environments, such as host name for ingress, Cloud SQL instance, and persistent disks. In the end, we install Kubeflow apps through KF Control apply command. Very soon, just after we master KSonnet, starting from version 0.6, Kubeflow uses customize as a default deployment framework. Since KSonnet project has reached its end of life, that's great. We will need to learn more tool. With customize, we can create overlays on top of base manifests for custom deployment. It was a little bit overwhelming to us in the beginning because instead of using KSonnet command line tool to update a few parameter files, now we own a tons of YAML files. But the process is similar. We first use the KF control to generate manifests. Then we create our own overlays on top of that. And in the end, KF control apply command to install all the Kubeflow apps. We are still learning the best practice of using customize. We hope with more knowledge, we will use it more wisely. Imagine in an ideal world, Kubeflow deployment changes can be tracked and updates in the components can be easily identified. In addition, if the manifests generated by KF control can be automatically converted to our own customized layout, Then we could use Argo CD to deploy all the manifests to our cluster with GitOps. We are working on this, and hopefully it will make our deployment much easier. With all these learnings and hard work, we have a Kubeflow platform that works for Spotify. People are getting excited, and they all want to use our platform to train the model. Now, how to manage the cluster becomes an important topic for us, especially around user access and resource management. Currently, we have about 100 Spotifyers using the platform, and they mostly interact with the cluster in two ways: Python SDK and Web UI. Python SDK is an internal library we built to help people to develop TFX workflow to run with Kubeflow pipelines. Web UI is mostly used to check experiment results and interact with pipeline output visualizations. First thing we need to make sure is only authenticated users can use our platform. Luckily on GCP, we can use Google RAP to secure our web UI. For the Python SDK access, it's managed by two layers. Google IAM assigns user a project viewer role, and Kubernetes RBAC grants user more granular permissions to access a specific set of APIs on a cluster. The other thing we want to make sure is that teams can use their own service counts to run jobs and read and write data. Usually, teams at Spotify operate in different GCP projects. We store service counts on cluster as secrets, so platform users can use them to trigger their machine learning workflow. We know storing service counts on cluster is not ideal, and we look forward to using Google Workload Identity in the future after multi-tenancy support is implemented in the Kubeflow pipelines. Meanwhile, secrets are backed up by Valero every hour, so they can be recovered if we need to rebuild our cluster. Apart from user access, various machine learning jobs have different resource requirements. We also need to design our cluster to address those needs, so teams can perform different types of jobs. Currently, our cluster offers 3 predefined node pools. One node pool is for standard ML tasks with balanced CPU and memory. Another one is for memory-intensive job with high memory machines. And the last one is for GPU training. When users write their machine learning pipelines, they are able to configure resource request and limit, so Kubernetes can pick the right node to launch the pod. And recently, we also noticed that when more and more users are using our platform, the default resource config is no longer sufficient for some critical service, such as STO policy, STO telemetry, and a metric server. We need to manually tune those resource parameters for them to fit our cluster setups and usage pattern. For this part, we are still learning the best practice to make our cluster more reliable. Okay, now we have seen how we build and manage our centralized Kubeflow platform. In the end, I want to show some stats of our platform usage. We launched our initial version of the platform in August. So far, we have already seen about 100 users using it and 50,000 runs on it. You can see from the graph, there was a spike in the middle. That was a renegade job running every 5 minutes to stress test our cluster. It took us a while to detect it since we are still in the alpha release. But the great news is that it was running successfully, and we even didn't notice it. So in the future, we definitely would like to have more monitoring of our system. With our centralized Kubeflow platform, ML engineers now can focus on designing, analyzing ML experiments instead of building and maintaining their own infrastructure. This makes the model iteration cycle shorter, and it results in faster time from prototyping to production. Eventually, we can have better ML models in our products and make our user happier. Before I conclude the talk, I would like to share several lessons we have learned along this journey, and I hope people who are working on a similar project find them useful. I remember when we submitted our proposal for this KubeCon talk a few months ago, we put something like, even with a handful of machine learning and data engineers, we are successfully able to manage multiple Kubernetes clusters and machine learning workloads at scale. Well, this is not true. Looking back, we definitely should work with Kubernetes experts from other teams as early as possible, because for ML data engineers, Kubernetes has a steep learning curve. Not only Kubernetes, building a centralized ML platform also involves knowledge around networking, security, deployment, resource management, a lot more stuff. We need to collaborate with experts from other domains, so it's a teamwork. Second, Kubeflow is too big to chew all at once. It has so many components, and each of them is very complicated. So you need to be patient and understand and use them piece by piece to fit your own needs. This is one of the reasons we choose to build a centralized platform. So we can centralize this knowledge in the infra team and let ML engineers focus on building products using our platform. Finally, nothing is small in terms of security. I encourage people to initiate a conversation with your security team as early as possible when you start building a platform for multiple teams, so you can address their concerns along the way and keep them happy. This is very important. That's all for our talk, building and managing a centralized Kubeflow platform at Spotify. If this sounds exciting to you, come join us in our awesome office in New York, Stockholm, Boston, or London. Thanks for your time. We were glad to show off what we have been working on. Happy to take any questions now. Thank you. Yes, please. Oh, this is this is the picture from our office in.
He's asking about you hiking in your.
Oh, where's my hiking? Yeah. Okay, this is in Glacier National Park. Yeah. So the question is, what kind of customization we have done for our GKE? Sorry, could you say that again? So another question is, does every developer have their own namespace? In terms of customization for our GKE, I think we have our own DNS server for our GKE, and we also have the shared VPC set up for our GKE cluster. That's the two main thing we have done for our cluster. Right now, since the Kubeflow pipeline doesn't have the multi-user support, so everybody is using the same namespace. But very soon, they're going to add the multi-user tenancy support. And so different teams can have their own namespace. Yes.
How do you manage resource quotas for GPUs? You mentioned you have different types of different types of workloads. How do you manage resource?
Okay. So the question is, how do we manage the GPU quota resource, right? To be honest, there are not many people using GPU at Spotify. The most of machine learning tasks at Spotify is for recommendations. So we didn't do any special stuff. It's just also the cost is not a main concern at this point for us. So we just offer everybody, if they want to use, they can use anything.
I think the question was, since there is no multi-user support, that one user can see everything, or within the namespace. Yes, however, we have some sort of workarounds so that the secrets that we have on the cluster are more secure. The question is the Terraform module that we use for setting up the Kubeflow cluster available?
Sorry, no. It's only available internally. Yeah. But it's quite a standard way how to define a GKE cluster through the Terraform. Yeah. Okay, so the question is the problems we are having migrating from customized to our own GitOps, right? And so the one major pain point we have is, so in order to make GitOps works, we need to structure all the manifests in a specific way so the GitOps can apply them through customize. But the KF control, when we use KF control to generate those manifests, it has its own file structure. So we need to have some process to convert the structure generated by KF control to our own structure. We are still working on that. Right now it's kind of a hand operation, but we want to automate the whole process. Have we done Kubeflow upgrade? Yes. So the first version we use is 0.5, then we upgrade to 0.6. Now we kind of halfway on the 0.7, only for the Kubeflow pipeline version. Yeah.
Do you run a pipeline all the time, or once a day,
You want that?
Yeah. So the question is, do we run pipelines every day or when we get new data? In terms of the Kubeflow setup, there are people running pipelines all the time, as sort of that graph showed. In terms of machine learning at Spotify, there are people who do daily retraining. There are teams that don't do daily retraining. Historically, we were using this tool that people may have heard of called Luigi, that was mostly designed for our data pipelines that do daily or perhaps hourly if you want retraining or running a pipeline. So a lot of people historically use that to schedule their training and depend on the upstream pipelines that create the data that they depend on. So we're moving away from Luigi with Kubeflow, but Kubeflow is still so new and there are a lot of people using it, but we're still very much in a transitionary period. All right, I think that's all the time we have, so thank you very much for coming.
Thank you, guys. Thank you.